Let's talk about the priority blocking queue, a prioritized queue for concurrent programming in Java. Imagine a queue where elements are not simply first in, first out, but are instead ordered based on their importance or urgency. This is the concept behind the priority blocking queue in Java. It's a thread-safe data structure that ensures the highest priority element is always at the front of the line, ready to be processed. Unlike the traditional queues, a priority blocking queue does not just store elements, it prioritizes them. This makes it ideal for scenarios where certain tasks or events need to be handled before others. For instance, in a task scheduler, critical tasks could be given a higher priority, ensuring they are executed promptly. To use a priority blocking queue, you simply need to add elements to it. The queue will automatically arrange them based on their priority, with the highest priority at the head. When you need to retrieve an element, you can use methods like take or poll. These methods will return the highest priority element, either blocking until one is available or returning null if the queue is empty. One of the key advantages of the priority blocking queue is its thread safety. This means that multiple threads can safely access and modify the queue concurrently without causing issues. This makes it a valuable tool for concurrent programming applications. So in conclusion, the priority blocking queue is a powerful and versatile structure that can be used to implement efficient and prioritized task scheduling, resource allocation, and event handling in Java applications. In comparison with the priority blocking queue, there is also the priority queue. While not blocking, the priority queue is essentially a non-blocking version of the priority blocking queue. It provides the same prioritized ordering, but does not block operations when the queue is empty. Okay, enough theory. Now let's get some code running. And don't worry, the entire code used in this video is uploaded on GitHub. This way you can check it at your own pace, as well as change it and use it to your pleasing. You can find the links to the GitHub repository in the video description below. Alright, so here we have a Maven project. And we also have build scripts and run scripts. Now, depending on your operating system, you will use the build CMD and the run CMD if you're on Windows, and you will use the build and the run if you're on Mac or Linux. Alright, let's start by creating a new class task. The first thing we want to do here is define a priority, which is a private variable of type int. We also want a description, which is a private variable of type string, but this could essentially be anything that you'd like. For this example, we're going to use this. Alright, let's create a constructor to take these values in. Public task. And the first parameter is int priority, and the second parameter is string description. First we remember the priority, saving it privately, and then we also remember the description, also saving it privately. Alright, let's create a getter, public int get priority, which returns the priority, and let's also create a getter for the description, public string get description, return description. Now let's override the standard string method so that we can return information of our class, the priority value, and the description value. Alright, in order to sort the task in our priority blocking queue, we need to teach our program how to do so. For that, we're going to create a new comparator, which we call task comparator. This class needs to implement the comparator, which as a generic has our task class. The only method that we're going to implement here is the compare method, which takes a first task and then the second task that we compare. Here we're going to make use of the integer class so that we can make use of its compare method, in which we just provide the priority of task 1 and the priority of task 2. Whatever comes out of the compare method prioritizes task 1 or task 2, depending if it's positive or negative, and the result will be returned to the caller of the compare method. Alright, let's get back to the main method and create a new priority blocking queue of type task, which we call queue, and in which we put a new instance of priority blocking queue with a capacity of 10 and our just created task comparator. Alright, now we're ready to add a new task. So let's do so, queue, add, new task, having a priority of 2, and the description we provide is mid priority task. Let's add another task of priority 1 and a description of high priority task. Let's add a third task of priority 3 with a description of low priority task. Now let's make use of a while loop, which runs as long the queue is not empty. Within the loop, we create a new variable task of type task, in which we put whatever the queue take method responds. Take meaning we get the top priority element. Now let's output this task to the terminal, so that we can see which one it is. System out println task. You might have noticed the red underline below the take method. This is because it is possible that this runs into an error, and this would be if take was interrupted. So let's use a try catch context to catch exactly that. And in case this happens, let's print an error, system error print line, take interrupted, message, and then the message of the exception. Alright, that's it. Now let's see how this looks in action. Let's build and run the application. And here we can see all our tasks. And as you can see here, all the tasks are sorted according to our task comparator, which sorts the priority to smallest number first, resulting in the first task to be taken high priority task, then the mid priority task, and then the low priority task. In summary, we first checked the basics of the priority blocking queue. Right after that, we created a code example showcasing how a collection of tasks is sorted based on the custom comparator we created. Okay, that's it for the priority blocking queue. What did you think about this short instruction? I'm sure you liked it, so please hit the like button. It helps this channel grow on YouTube and make sure this type of content can help many others interested in this topic as well. Also, subscribe to this channel. This is the best way to get notified about future videos with content just like this one. Thank you very much for watching. My name is Gene. See you in the next video.